Hello everyone, welcome to the OneClass channel. My name is Shenaeze and I am a second year student at McMaster University in life science and minoring in environmental science. Today we'll be going over some commonly asked mathematics questions at both the high school and college levels. If you need some homework help or tutoring, check the links in the description below. Okay. So in the first question over here, we are asked to convert 800 meters to miles. So the first thing that we do when we're given a conversion question is to figure out the conversion factor. So in this case, the conversion factor is 1 meter equals to 0.06. 2, 1, 3. Seven, 9 miles. So what we have to do is we have to multiply 800 by this conversion factor over here. If we were asked to do the opposite, so convert from miles to meters, we would have to divide miles by this conversion factor to get the meters. So that's going to be the conversion factor times 800. And that, if you put it in your calculator, would equal 0.49. You can leave it at 3 decimal places, so I'm just going to put 0.497 miles. And that is our final answer. So the next question is, what is the quadratic formula? So for those of you who don't know, the quadratic formula is used to find the x-coordinates of a quadratic function, or the roots. So the equation, or like the formula of that, is x is equals to negative b plus and minus. So when you're solving, when you're putting in your values for a, b, and c, you're going to get two different x-coordinates. One if you use the plus over here, and the other one if you use the minus over here. So square root b squared minus 4ac all of that is over 2a. So the values that you're going to get, the a, b, and c, is from the standard equation of a quadratic function. So it has to be in the form of a x squared plus b x plus c. So that has to be the form of the equation. If it's in vertex form or any other form, you have to convert it to standard form if you want to use that. Okay. So again, it's just that. There are always two answers, so one of them is, again, with the positive, so you get rid of this negative, and you do negative b plus square root b squared minus 4ac over 2a. There you go. And the other one would be negative b minus the square root of b squared minus 4ac over 2a. Another way you can figure out how many roots or how many solutions or how many x coordinates the function that you're given has is by using the equation b squared. So just the part that is underneath the square root. So b squared minus 4ac. Whatever value you get from this, if it's a positive number, so above 0, then you have two functions. Then you have two x coordinates or two solutions, the function. Greater than 0, then you have two solutions. If I'm just going to put 2 here. If the value of b squared minus 4ac is equals to 0, then there is only one solution to the whole function, which means that the function only touches the x-axis once, or goes through the x-axis once. And lastly, if your b squared minus 4ac is a negative value or less than 0, then your function does not have any x coordinates or like two complicated solutions. We can do an example using this. So we're given the problem 5x, sample problem as 5x squared plus 6x minus 1. So that is our sample. So we can easily figure out that the a value over here is 5, the b value is 6, and the c value is -1. So we just need to put that into our equation. So first x, we're going to use the positive one, so it's going to be our negative b, so -6 plus the square root of b squared, which is 36, minus 4 times 8, which is 5, times -1, or like c, which is -1, all over 2a, so that would be 10, because 2 times 5 is 10. This then we can simplify to 20. 4 times 5 is 20, times -1, so that cancels out. So that's going to be a positive, let me get my calculator, 36 plus 20 is 56, -6 plus the square root of 56 over 10. We can then simplify the radical. If we take out 2, we're going to be left with, to simplify the radical, we can think of numbers that are perfect squares, or things that make up 56, or multiples of 56. So we can try 4. So -4 times 14 is 56. So the square root of 56 is also equivalent to the square root of 4 times the square root of 14 over 10. This can be further simplified into 2, so that's going to be -6 plus 2 to the power of 14 over 10. We could leave it like this, or we can factor out the 2 if you want, because 2 is common here, 2 is common here, and 2 is common here. So we factor the 2 out. It's going to be -3 plus the square root of 14 over 2 to the power of 5. Again, we want our answer in the simplest form possible, and these two are going to cancel out, and so our final answer is going to be -3 plus 14 over 5. Plus the square root of 14, sorry. We can use the same exact method that we did over here, plugging in the same numbers, but just the positive sign over here would turn into the negative sign. If we do that, we're going to be, so that's our answer for x1. x2, you can use the same method, just make sure to put the minus sign instead, and we're going to get -3 minus square root of 14 over 5. So those two are x coordinates for the function. Okay, so in this equation, we're asked to isolate for x from this equation. So the equation is ax plus b is equals to c. So when we're asked to isolate for a variable, we have to make sure that it is on its own. It's not being multiplied by anything, or added to something, or subtracted by something, or divided by something. It's just there by itself. So that's what we're going to do here. So the easiest thing to get rid of on this side of the equation is b. We could do that if we minus b on both sides, because then again, if what you do to one side, you have to do to the other side. So ax plus b, I'll rewrite that, and then minus b. So we're minusing b from both sides. This is just going to be c minus b. That gets rid of our b. So we're left with ax is equals to c minus b. The next thing to get rid of is a, and we can do that by dividing a on both sides. So if we divide this side by a, I have to divide this side by a. These cancel out, and we're left with x is equals to c minus b over a. As our final answer. This is another conversion question. So, what is 5 kilometers to miles? Again, we have to figure out our conversion factor. So, our conversion factor is 1 mile is equals to 1.6093 kilometers. 1.6093 kilometers. Okay. We're asked to convert from kilometers to miles. So in order to do that, we have to divide by the conversion factor. So we have to divide 5 kilometers by the conversion factor in order to get the miles. If we had to convert from miles to kilometers, we could just easily multiply the miles with the conversion factor over here, which is 1.6093 6093 to get the miles. So 5 kilometers times 1 mile is the conversion factor. Once you put this in the calculator, you get 3.1. Again, leave it at 3 decimal places. 3.107 miles. And that is our final answer. Always just remember, when you're given a conversion question, the first thing to do is figure out the conversion factor, and then see what if you have to divide by the conversion factor or multiply by the conversion factor to get your final answer. Our next question asks what is the y-intercept of the line y is equals to x plus 2. So when you're given a linear equation, the y-intercept is when x is equals to 0. So in order to find our y-intercept, you have to make sure that our x is 0. Again, the equation of a line is y is equals to mx plus b where m is our slope, b is our y-intercept, and x and y and x are our coordinates. So basically what they're asking is when the graph, so for example here, that's just a random line, when the graph intercepts the x, this point right here, or here more so, they're asking when the graph, or when the line intercepts with the y axis. In order for that to happen, we have to make sure that's our x, that's our y. We have to see when x is 0, because of here x is 0. So in our equation, when is x 0? In order to do that, we just simply put y is equals to x plus 2. That's our normal equation, and we have to make sure that our x is 0 for this. So y is equals to 0 plus 2. Y, which is equals to y is equals to 2. And that is our answer. Our y-intercept is 2. You can also put it, this is just in that form, if you want to put it in vertex form. Oh, sorry, not vertex. If you want to put it in the coordinate form, just put it when x is equals to 0, our y is 2. And that is our y-intercept. could have tried this with a different question. If it was something like y is equals to x plus 9, we put our x to 0 and we get y is equals to 0 plus 9. So our y would be 9 and our final answer would be 0 comma 9 would be our y-intercept. Okay. This is a really simple question, but let me go through it. How many zeros are in a billion? So we're going to start out with our first unit measure, 1. Then we're going to add another 0. So that's our tens. If we add another 0, that is our hundreds. If we add another 0, that's our thousands. So that's 3 zeros. And we've reached 1,000. If we add another 0, that's our 10,000. Another 0 would be 100,000. And lastly, another 0 would make it 1,000,000, because we all know that 1,000,000 has 6 zeros. If we add another 0, that's 10 million. And another 0, it's going to be 100 million. And lastly, if we add another 0, that is 1,000,000,000. So the question asked, how many zeros are in a billion? Just add these up. And our final answer is 9. So there are 9 zeros in a billion. This question says how to convert 5 kilometers into miles. I feel like I've done this one. But, so first things first, we figure out our conversion factor, which is 1 mile is equals to 1.609 kilometers. Then we look at our given function, which is 5 kilometers, and we need to convert that into miles. So we're going to have to divide by the conversion factor. Again, if it was from converting from miles to kilometers, then we would have multiplied by the factor. But in this case, we're dividing, so 5 times 1 mile is equals to 1.609 kilometers. If we put that in our calculator, we get 3.1075. Just leave it at 3 decimal places. That is our final answer. So in this question, we are asked the value of log 1. So what is it essentially asking is, if there is no base number shown over here, we have to assume that our base is 10. And then it's quite simple. It's just figure out to what power of 10 do we multiply to get 1, and that is by 0. So 10 to the power of 0 is 1, so our answer is 0. That's our final answer. Those are all the questions that we're going to be solving for today. If you guys want to submit your own questions, check the links in the description below. This was Shenaeze from OneClass, and